having. So this presentation is going to be a bit different because I had something else totally planned for, for the whole presentation, but sometimes that doesn't work. So we'll try to improvise. So let's see if we can do it like this. Okay, so I'm from what we call the Generation X. Okay, so I'm born in the 80s. I grew up in the 90s. And I've basically been ushered into the digital era with technology evolving around me. So we got cable TV, we got laptops evolving, we got flat screens TV, and of course the internet. So the internet was a big thing. I was actually pretty late. I got my first computer when I think I was like 13, and that was 1998. So that's when I first got onto the internet. But ever since then, you've seen the internet evolving. You've seen what technology can do, and there's a lot of talk about machine learning and, of course, deep learning. And being a Generation X kid, I, of course, played a lot of video games in my past. So this is an outtake from that part of my life that I thought was pretty interesting. So there's a company called, or a non-ideal organization called OpenAI, and it caught my attention because one of the persons behind that organization is Elon Musk from Tesla. I think he left now for some other project, but he was supporting that organization into developing machine learning and also deep learning. And they made some pretty cool breakthroughs when it comes to machine learning. They actually developed a neural network and a machine that was able to play Dota, and it's Defense of the Ancients, if you heard about that. It's a spin-off of a game called Warcraft, which was released back in the beginning of 2000, and it's been really popular. And being from my generation, esports is of course a big thing. That machine was actually able to learn 180 years worth of playing that game. So it managed to teach itself basically everything there is to know about that game. So everything from how to win, how to collaborate with your teammates, what is a win, what is a loss, and even getting to know what a reward is. So when the machine would lose or lose a teammate, it would take that as a bad experience. And if they would win, they would take that as a good experience. So taking emotions aside, that's a pretty big thing for a machine to be able to accomplish. And it even caught the attention of Bill Gates, which basically said that, due to the fact that they were able to collaborate and learn what teamwork is, that is a big thing for machines, okay? But machine learning is all around us, and also deep learning in our everyday. Netflix is using it, for example. We have Spotify. We have different kinds of companies that are using machine learning in order to learn what you like, what your desires are, what your needs are, and tailor that experience to fit you, okay? So they want to learn exactly what you like, so they can tailor an experience according to what your needs, basically. And another really good example of how deep learning is utilized is banks. So banks are using that to detect fraud or scam. So for example, if you were to put in your credit card in a ATM in Latvia, for example, and then a couple of hours later, that same credit card would be used in, for example, Australia, then that would trigger a mechanism in that deep learning engine telling it that it was some kind of fishy activity. Machine learning is complex. It takes a lot of data in order to get an accurate model of what machine learning is. And looking at this picture, for example, you can see that there's a lot of work that goes into discovering the attributes of a human face. And in this case, the machine learning engine thought that, well, Saruman looked a lot like that dog in this case. So that was what machine learning in this case could determine out of that picture. All right. So what we're doing with machine learning and deep learning is what we call predictive security. So we're basically taking that approach to detecting what is good and what is bad. So going back to what OpenAI did with the video game, for example, they're using that deep learning engine to teach the computer to win in a game. We're trying to teach our deep learning engine how to win against hackers and being one step ahead of everyone. So that's what we mean when we talk about predictive security. So we're trying to determine what is a bad file and what is a good file. Okay, so we're trying to use the deep learning engine to determine if a file is bad or if a file is good. And also to discover what we call grayware or potentially unwanted applications. So files we have never seen before, unknown malware, unknown executables, are being discovered by the deep learning engine, which has taught itself, using what we have taught it, how to identify what is a malware and what is not. So looking at the machine learning versus deep learning, it's a quite complex structure, but I'm going to try and explain it in really simple words. So machine learning is basically using a decision tree to determine what is bad and what is good. So we're asking it simple questions, and this requires a lot of input from a human in this case. So we're asking, is this a file you've seen before? Yes. Okay, does it have these characteristics? Yes. Does it resemble a virus? No. So that would give you an output that this is probably not a virus in this case. Whereas in the case of deep learning, and our engine, in this case, or the algorithm, it's actually got its own neural network. So it's using its own patterns or attributes that that we have taught it in the past to discover by itself unknown malware and what is malware in case of, for example, new files, unknown files, and also potentially unwanted programs. So, for example, if you see someone with a ski mask in the middle of the summer going into a bank, that's pretty suspicious, right? So in the case of deep learning, we would then determine that the ski mask summer is probably not a good thing, right? Same goes for if, for example, you see someone wearing a Santa Claus hat in the middle of the winter, that's probably nothing to worry about, right? So that's sort of how we determine what is good and what is bad. Looking at the idea behind predictive security is, of course, to achieve perfect security. So we want to have as good hit rate as possible. So we want to be able to detect 100% of all malware that is out there. We know that that is near impossible, but we can at least try to get to 99.9, right? And in order to do that, we need to have deep learning in our backpack, okay? So we need to have that working for us in order to determine what is bad and what is not, and also discovering new malware. So looking at traditional antivirus solutions, we see that they have about a 50% perfect security rate, whereas they have a pretty good false positive rate. So that's also what we call the user annoyance level. So if the user gets annoyed, it's a bad solution, okay? So then we have too many false positives. We took one step further and developed machine learning for endpoint security, and we got closer to perfect security, but we got a much higher false positive rate, and that is because the machine learning engine wasn't ready to determine exactly what is good and what is bad. It had too many false positive and not enough false positive mitigation techniques within the algorithm in this case. Whereas going to Sophos and the deep learning engine that we have developed, we actually got closer to perfect security, and we also managed to get closer to a low level of false positives. So that was a huge win in this case. So the deep learning engine has the capability of acquiring a high security score, but also keeping a low false positive score, and also thus making sure that the user annoyance level is low. We have incorporated this in a couple of our products, but the most prominent one is, of course, Sophos Intercept X, which we call the power of the plus, because we have a multiple layer approach to security. So, of course, you would need to have the traditional antivirus solution in order to detect what is known. And you also would need to have a ransomware protection, which we call CryptoGuard. We have also empowered it with AI or deep learning, which I've been talking about, and of course, anti-exploit technology. So all of these layers are included in Intercept X and are working together in order to protect machines and endpoints from unknown malware, unknown executables, fileless attacks, etc. And something that we just released and something that is helping you in order to investigate or see what is not there is something we call EDR, so endpoint detection and response tool that is included in Intercept X. So with the EDR, we're giving you the ability to easier easier visibility and detection, because that's always a problem in solutions. So you have a blind spot because there's a lack of reporting and a lack of investigation into what is going on. And then, of course, you have the analysis and investigation, which is also something that is time-consuming. It takes a lot of time to do, and you need a lot of expertise in order to do so in a more efficient manner. And last but not least, the incident response is something that is a problem, because you need to have the right personnel, and you need to have the right personnel at that time, which costs money, costs time, costs resources. So this, of course, will overwhelm the customers and the users, because there's too much information going through the endpoints. There's too much information going to the firewall. So you need some kind of funnel in order to summarize that and aggregate that into a solution that will tell you exactly what is going on, and to simplify it and making it easier for you. So in comes Sophos X, Sophos Intercept X, and EDR. So the EDR is basically capable of giving you the ability to, first of all, detect what is going on using the deep learning engine and also the anti-exploit technology and all the layers in the endpoint. And second, we are helping you investigate. So there's more clarity and less noise. So we're basically taking all the information that is going to the endpoints and simplifying the visualization for you, so you can read about what's happening and you don't have to dig deep and waste your time into data that is unnecessary, basically. And of course, we're able to respond, so automatically responding to the threat without you having to be involved. So that's what we call automatic remediation. We can respond to the threat, making sure that we isolate the problem in a computer, so you have time to investigate what is going on. Which makes it possible for you to save a lot of time, because we give you the tools to become a forensic specialist without being one. So basically, having all these three functions is probably really expensive, and usually companies don't have that, because they are expensive people, these security analysts and forensic specialists. So you don't need to be that. I know that it's really hard these days to be everything. You need to be an administrator, you need to be IT security specialist, you need to be a complete IT rock star in order to do everything that is needed of you within the company. So adding forensics specialists to that is a pretty big role, right? So we're giving you a tool that is helping you to do that job for you. So we have Sophos Labs and we have deep learning doing all the work for you, which makes it possible for you to focus on other things, but also giving you the visibility and being able to detect the unknown variables within your network. So for example, if you have an infection, if you have latent viruses or malware within your network, we're giving you the clarity and the visibility to see that and what is going on. Now, I was going to show you a demo, but due to technical difficulties, I can't really do that. Yeah, the demo is actually on my computer, so that's the problem. So if you're interested in seeing how this works in action, I can actually show you back at our booth, at the Sophos booth, because I have it ready on my computer. And without further ado, I'm basically thanking for myself. And if there's any questions, just let me know. Make sure you come to our booth and I'll show you the demo. It's really cool. I promise. It's worth your time.